Hello friends, welcome back to the Test-Driven Development Screencast. My name is Joff. In this video we're going to be talking about contract tests. So in the previous video we've come up with a fake that is supposed to substitute our real backend, which we don't have at the moment. So the idea is that we are going to leverage this fake in order to get as much of the behavior of the real backend as possible. So now, because I don't have real backend, I wrote down what are the things that I would care about having a real backend. So because there is no specification, I just came up with things. But if I had that, would have been maybe easier. Anyway, let's see back in the code what we've written down here. So in the previous episode, we wanted to make explicitly the bad search, which was sort of an exception that our upper levels are dealing with. It should be thrown explicitly from our fake, and also the offline part. We want to make that part of the contract. But of course, if we had another behavior that is really sort of interesting and important for us at this moment is like when we pass a query and when there are no matches on the backend for that query, we should get back no results, essentially an empty list. So let's write that down. So it would be an empty result. And another one is the actual matches. So if we had like the idea here is that we're gonna we want to make sure that we have a contract that behaves that would explain how we expect an implementation of real thing to behave using the fake. So let's see how that's gonna work. So first of all, we don't have a test case for this one. For the InMemorySearchService, I'm gonna go ahead and create a test, and I'll leave the name as InMemorySearchService test, because afterwards we are gonna create, we'll come up with a contract that will be SearchService contract, let's say. Okay, I'll move it on the other side, and I'll also remove the internal keyword here because the test suite might not find this test case if I leave it. So as I said, we are gonna start with the empty results. Let's say return empty result. And essentially I want to make sure that the result is going to be an empty list. And I think I have to explicitly say here the type. And that's going to be my result. And the result will be a whatever comes from the search service. Dot find matches. And here I'll pass an item. Let's create an InMemorySearchService. Okay, I have a typo here. And here as well. Yeah. So here I have to provide some values. So if I, for example, say here and a list of, which is essentially an empty list, this test will work. But what I want to do is I want to make explicit that I have a InMemorySearchService without values that are matching the given query. So I want to make that explicit in this test. So when I have a search service without such values and I search for query, search for the given query that is not matching, obviously, I'll have the empty result. So let's say, what if I have here, for example, item 1 and if I have an item 2, and if I run, this will fail because now it does return both of them. And how I can make this to be explicit that I don't have these two, item 1 and item 2, I can reverse them back, so from back to front. So for example, I can do a map here, reversed, and if I run, this should work, and that would allow me to, if I make a variable out of this one and say that these are the available values, what I can do is actually make this one, I'll extract it into a function that I can say search service without. Now the intention of this test is getting way better. So if I inline now here this, I can say I have a search service without item 1 and item 2. Then I search for an item and I will get back a empty list. So that's what I want. And this test passes. So let's check this in. And I'll say returns empty result when no values matching the query. Oops, type again. And I can do a little formatting here as well so we can see the whole code. And I want to explicitly here say the type of the search service, which is the interface that we ended up with previously. I want to convert this into a block body. So if I run, it should still work. Yeah, and I'll extract this one into variable. I'll say reversed values. Cool. And now I think it reads slightly better. Let's check this in as well. Improve best. Improve the code. Okay, I think the empty result is okay. Now let's focus on matches, and I would say return matches. And it's gonna be a list of let's say, come on, item 1, then item 2, and let's say item 3. That's gonna be the result. And the result's gonna be again search service find matches, passing there an item, and that's gonna be a in-memory search service. Now here I want the service to have more than just these three these three values that I'm expecting back. So I'm gonna have variety of values there, and only these ones are expected to be back. Something like 1, then item 1, then 2, and let's say item 2, else, and then item 3. Let's run. Of course, this behavior is covered with the previous tests that we had. But the thing is that I want to make this explicit as part of the contract. I want to make sure that when I have a search service with these values and I search for, let's say, given query, then only the ones that are expected. I want to make that explicit part of the contract. So let's see. So what we can do here. I want to first let's inject here a little defect just to make sure that we are there, of course. Now I'll make that pass again. Let's first check this in, and I would say return matches for given query. Then these are gonna be my available values, and that's gonna be a function search service with. Now that's the important part here, so I don't want to do that. So I have search service without some values and then search service with some values, and then when we let's make sure everything works. When we see here in the test, when we look at the test, let's maybe inline this as well. I have a search service with list of bunch of values, and then I search for item and I get back only the one. So this is really clear intention that I have in this test. It works again, and what I want to do here is to do the same formatting, make the type explicit. We're gonna take a look why this type is important to be explicit here. And yeah, I want to convert to block body. I want to make it, you know, consistent. Cool, it works. Let's check this in. I would say function extracted function that provides search service with values. Okay, now that's for the matches. Now we want to work on the bed search and the offline. So let's continue with the bed search. So how do we mimic now the bed search? So now if I pass, if I had a real backend and if I pass there a empty query, let's say, when I pass there an empty query, it will have to do the validation itself. Of course, I have a validator here in my solution, but the thing is that I could call the backend without making validation on the query, right? So the backend will do the validation itself as well. And in case I pass there a query that is not valid, I expect it to return 403, let's say, and that's gonna be the bed search. That's how I'm gonna mimic. So the essence here is that this fake that I have, the InMemorySearchService, will have to mimic that backend behavior. So let's see how we can do that. So throws a bed search exception. Instead of the assert equals here, I would say assert throws a bad search exception when I do search service find matches, and I'm gonna pass their blank query, and I'll create local, and that's gonna be my InMemorySearchService. Now it's irrelevant what I'm gonna pass there as available values. I can pass empty list because I won't. The idea is that I won't even touch the values if I pass there a bad query. And this fails it fails because I expect bad search exception, but nothing is being thrown. So here I can do if query is blank, throw a bad search exception, and that should make the test work. Cool. So I can check this in. The in memory search service throws a bad search exception. Okay, and then I'll do the same here. I will extract a function for this case, and I'm gonna name this unavailable search service. So my search service is unavailable search service, and I want to make sure that it throws bad search exception when I pass their query. And the same, I'll be explicit about the type and convert to block body. And that should still work. And let's check this in, and that's gonna be extracted a function to provide an unavailable search service. Okay, and finally we can work on the offline part. So I'll write a new test, throws an offline exception, and I'll say assert throws I think it was connection unavailable. Yes, that's the exception that I want. When I do search service find matches, now the query doesn't it doesn't really matter what I'm gonna pass as a query as long as it is valid query. But now I have to mimic an offline search service. So how do I do that? Essentially I can pass null here. Of course now it doesn't compile because it is not, the InMemorySearchService does not expect a nullable type, but I can make that nullable. And then in my code, in the fake, I can use double exclamation mark just for the sake of running the test. I want to make everything compiling first. And the test says that I expect connection unavailable, but it was null pointer. And indeed, because I'm passing there a null, and use the exclamation here. So how do I make this work is I can say filter or otherwise throw a connection unavailable exception. And now that should make the test work. Yes. And I can say in memory search service throws a connection unavailable exception. And just as we did before, I can extract a function for this one as well, and that's gonna be offline search service. That should still work. And now I want again the search service like that. It should still work. Yeah. And let's check that in as well. Extracted a function to provide an offline search service. So now the idea is that I have these functions here and they all return search services type. And now we can extract a contract so we can see why it was important to have that type there. So what I can do here is I can extract superclass into a separate file. I'll name this search service contract. Now the idea is that the tests, all the 4 tests, are gonna be part of this contract, and also the functions that are providing the search service implementation are also gonna be part of the contract, but they are gonna be abstract. That's the important part. So I'll select all of them and mark them abstract, and I'll do the refactoring. So now the contract, if we take a look, let's start with a contract. Now my contract here, I think some imports are missing. Okay, I don't know why the Android Studio is not making that automatically. Anyway, now this is the contract. Now in the contract here, I have all the tests, the 4 tests, and I have functions that each implementation of the contract will have to provide. So the implementation will have to provide, the test case that derives from the contract will have to provide offline, unavailable, search service with, and search service without. And that's why it was important to have the search service type. And now, having this contract, all the tests should still work. And if I look at the actual implementation, the InMemorySearchService test, it just overrides those functions and it provides there a type of search service. In this case, it is the InMemorySearchService, which is the fake. So that's how we leverage the fake in order to create the contract tests. And now it actually defined the contract, and now it also complies on the contract. Now we're gonna see in the following episode, we'll write another implementation of search service that will be doing a let's say real call to a backend, and it will have to also comply on the same contract. So it will have to pass all these the tests in the search service contract. So we are gonna see how that's gonna work. And what I can do here now is I can I have to check this in, of course. Extracted search service contract test. And I think that all the tests are passing. And now if I go back in my to-do list, I'm done with the contracts actually. And I can actually close this file now because I'm planning to have one more episode where we'll write the another implementation of this one that does the call, and maybe then afterwards a retrospective. But essentially this is how the contract tests are working. Really for me this is really essential part of the entire the entire exercise. So having these contract tests, I don't have to, I can, if I want to write integration tests, I can actually derive from the contract test and make the integration test. So I'll have little or like small set of tests that are gonna be the integration test, and I can actually separate them to run on a different process than all these fast tests, the micro tests that I'm gonna have. So they won't interfere. Let's say when I'm test driving some code, I'm not gonna have to wait or make real calls or do that kind of things. which I'm not big fan of, like making real calls when having a test. But some people do integration tests with invoking real calls, and even in that case, I think having this sort of contract tests is sort of helpful. Anyway, I think we are gonna write a new implementation in the following episode. I think we are done with this one. Thank you so much for the time and for the attention, and I'm gonna catch you in the next episode. Stay safe.